Hey Finxters, what's up? It's Chris, founder of Finxter.com, and in today's video you're going to learn about the Python is and is not operators. So these are two Python keywords, basic Python operators. It's part of my series about all Python operators, and you really need to understand these operators. No matter whether you are already an experienced coder, you should know them by heart. You should understand the details of these operators, or you are a complete newbie, then of course you need to learn about those operators. So the is and is not operators, if you for example open a Python shell, like here I have an open shell, you can do the following. For example, you can create a list 1 of 3 values, 1, 2, 3, and you can create a second list called list 2, and say it consists of the same elements, right? Now many people know the equality operator with this double equal symbol, right? So this double equal symbol basically helps you to compare different objects against each other. So for example, you can have object behind the variable list 1 and compare it against the object behind the variable list 2. So you can element-wise, in this case, actually perform the comparison. And we have already covered these arithmetic operators like the equal operator, and you see now if you compare those two lists, they are the same, right? So Python gives us the output true. But then there is another comparison operator, and this is called the is operator. So we start with the is operator, and this is called the identity operator. And the purpose of this operator is not to compare those element-wise to check if semantically they are the same, these objects, because they are the same. We already know from the equal to operator discussed here in this previous example. But it helps us to check whether both objects actually refer, both variables, list 1 and list 2, refer to the same object in memory. So what does it mean? So let's open, say, a drawing board and say this is our computer memory, right? So what you can call RAM, random access memory, and this is where actually our program lives. This is where the variables live, where the objects are created, and so on. And now in a certain Python code that we have discussed here, like in this Python code, we create a variable lst1. So here we have lst_1. We create another variable lst_2, and we create the objects behind these two, right? So for example, we create an object. Now this may be like a list object 1, 2, 3, and basically, like if you would really dive into it, then basically a list would be simply an object. So the list data structure would be an object with references, and the references would then point to our integer objects 1, integer objects 2, and integer objects 3. And then we have another list object, and maybe these pointers, so these different list elements, they contain the same integers. We have already seen both contain the integers 1, 2, 3, but actually Python internally represents it as many other object-oriented programming languages with object references, right? So you have like a list of references, like here a list of 3 references, and those references point to existing objects in memory, right? So you see now on a high level, this is one object, and this is one object. We have 2 list objects, and our list 1 variable points to one object, whereas list 2 variable points to another object. So if you would change this, say we append a value 4 to this first object, then the second one wouldn't change. It would still contain the original 3 elements. Nothing would change for the second variable, right? So they point to different objects in memory. And sometimes, like this scenario, is very different to the scenario where we have, say, list 1 and list 2. Now abbreviated a bit, we have one list data structure. Now they both actually point to the same data structure, right? The same object. Because now if you change this object, say we add another element 4 to this object, then both variables will see it, right? So these two cases are quite different. In this case, we have the aliasing problem. So both variables point to the same object in memory. If one variable changes, so if for example, if you change L1.append, so you append an element to the first list variable, then actually list 2 variable also change because both point to the same object. And I will give an example in a moment in Python code. And here in the second case, if you change the first list, actually the second list variable is still the original one, so it hasn't changed. Good, so let's check this out in code. So here, now we have, in this example, we have created two variable names, list1 and list2, and both point to some object, some list object in memory. And here, basically, we have already checked both list objects can be considered the same semantically, but they are not the same when using the identity comparison is, right? So because what we have discussed here, because they point to different objects in the random access memory, in your computer's memory. Okay, and so for example, now what happens if I append an element to the first list? So now we can call append, say, element Alice to the first list. Now if you print the first list, it looks like this. If you print the second list, it is still the original list. So this is the example we have seen here, right? So if you change one element here for the first list, then the second list variable wouldn't actually see. There's no aliasing problem, right? There's no, like, if you change one variable, the other variable wouldn't change. But if you do the following, you can also do the following. So if we like forget all this code, if you would refresh the shell, now we can create a variable list1, 1, 2, 3, and variable list2, and this just points to the original variable list1, which means that if you print list1 and you print list2, both look the same. Actually, this example looks much like the same as the previous example, right? But now if you use the is operator, you see both, so the result is true, so therefore they are both identical. They point to the same object in memory. So if you change one object, like we append the name Alice to the first list, now if you print the first list, of course we have the name Alice as before, but if we now print the second list, we have the aliasing problem, so both now contain the new element Alice in the list, right? So this is why actually the is identity operator exists in the first place, just to check the whether those two variables point to the same object in memory. And how does it work internally? So internally, Python uses the ID function, which is defined for any object. It is the ID functions. For example, you can pass an object like a list into the ID function, and it will give you a numeric representation of this is like the memory. A representation of the memory address. So it's a number created once for each object, and it never changes for this particular object. And for example, if you print now the ID of list1, it has like a different number. This is a different number. So we have 19656, and here we have 19655. So it's a list1 variable, even containing similar elements initially. It points to another memory address, right? But if you now check out a list2 variable, here previously we have checked list1 is list2. So we have simply assigned list1 to variable list2. So both point to the same object. This is like this second example, which like the left example. So if you check the ID now, these are basically the same, right? So this integer number, this memory representation location is the same as this one. So you can also check it like this: ID lst1 equals to ID lst2, and you see it's true. And basically this one is just a longer form of checking list1 is list2, right? So this is just these two are semantically identical, and Python internally actually uses the ID function to perform this is operation. Good, so far so good. So I hope you understood this basic example, and if you understood this, it's basically simple to understand the is not operation as well. So if you have if you can check the is operation, list1 is list2, then we can also understand the is not operation, right? So intuitively, if the first one is true, the second one should be false, right? So it simply inverts this. And so, for example, if you have two identical objects, say we have a string variable hello Finxters, and the second one hello Finxters. So strings are immutable, which they cannot be changed afterwards, and therefore if you check the is operation on two strings, basically they often refer to the same object. In this case, no. In this case, they are really different objects, so it really depends on the application scenario. But for example, let's see if we can come up with an example. Hi is high. Now in this case it's true, right? So we can, for example, now use the is not high operation, and this is then just the inverse, right? So if it is originally, if it is true, now it is false. If you check s is not t, which previously was false for the is operation, now if you use is not, it is basically true. So it's always the inverse. If you like, the not operation simply inverts the Boolean output of any operation. Okay, so this is how the is operation works. Identity operator works. It's very simple, very straightforward if you understand it, but you need to you should know that the is operator is implemented using the ID function, and you should know that the ID function is actually often used to check the memory location of a given object in order to compare, to know what happens in a Python program or Python script, whether you actually have some aliasing problems or not. So if you are an experienced Python coder, you will know that there are so many occurrences where this shadowing or aliasing problem, where one variable points to the same object as another variable, it often leads to bugs, right? So because if you change the object on one variable, you don't expect that it changes for the other one as well, but then you really have, for example, you have passed an object into a function, the function changes the original object, and now this is visible to all other code parts as well, and this is often not what you actually want to accomplish. So you need to know about these debugging tools like the ID function and the is operator to understand Python. And also, like, one thing I should note, often you check something, so for example, say you create a function f and you check, say the function f takes one argument x, and now you want to check if x equals none. So this is what many coders actually do. You want to print something, please type value, something like this. Okay, so now you have defined function f, and if you, for example, pass none into it, it actually gives you please type value. But in none is a singleton in Python, which means that there only exists one value, none, in memory, and therefore it is more precise, actually not more Pythonic, to check if x is none. Okay, because this one checks if they refer to the same object in memory, and as experienced Python coders know that there's only one none value, it is often a bit more precise because it's most specific, most clear. There's most there's minimum hurdle, so minimum wiggle room actually. That's why you should actually use the is keyword to compare, to check for such a singleton in Python. Okay, so it looks the same, the behavior is the same in many instances, but this one is not so precise because it's just you use the is keyword, the identity operation, to check if an object is identical to another object. And in this case, you have on the left you have an object, and on the right you have an object, none, and therefore you check it. You like check the identity of these two objects rather than checking for equality. Okay, so I think this is enough for the Python is and is not operators discussed in this video. Thanks for listening to this video, and I'll see you in the next one. Bye.